Hey Fox, in the previous session, what we have learned is we have basically understand the high level overview of this entire use case, which is exactly supermarket sales. So in this session, what we will do is very first we will import our data and then we will do some basic data pre-processing and basic data cleaning wherever there is a need. And after that, we will gradually move towards statistical analysis, some basic data analysis, some advanced data analysis, and at the end, we will end up having our meaningful insights. That's what we will do in this entire use case. So very first, let's try to import some of the amazing library, let's say pandas, numpy, what is matplotlib, seaborn, what is OS module, and all these necessary modules to interact with data and to do several manipulation and to perform some advanced analysis. So very first, let me import my pandas module and I'm going to create its alias, let's say SPD. Then I'm going to import my numpy module, which is responsible for performing all the numerical computations on this data. Now once I will import my numpy, let me import some other module, let's say exactly my matplotlib, and from this I have to import this pyplot and I'm going to create its alias, let's say plt. Then I'm going to import one of the amazing module, of course, for better visualization, which is of course my seaborn module. So I'm going to say let me import, let's say seaborn, and I'm going to create it alias as SNS. Let me just execute using Alt plus Enter. Once this cell gets successfully executed, now what we have to do is, let's say very first, let's say we have to read our data. Let's say before reading data, let's say we have to interact with our operating system. So what we will do is we will import one of another module, which is exactly my OS module. So using this OS module, we can interact our operating system. Let's say, hey, can you manipulate some files or can you create some files? So using this OS module, you can perform all these tasks over here. So I'm going to say inside this OS module, I have an amazing inbuilt function, which is exactly list dir. And if I will press Shift plus Tab over there, this is all about the signature of this function. So what it will return us basically, it just return a list that holds all the names of the file in the directory. So over here, basically, we have to pass the path over there. So I will say from this, let me just copy where exactly my data is available. So what I will do is I will say, just copy this entire path and over there, let me just paste the entire path over there. Now, once I will paste it, what I will do is I will just execute these blocks of code. What it will return us is, it just return all the list of the files that are available, whatever path you have mentioned over there. So it says here, at this path, we have a one data set that is exactly my supermarket sales data set. Now we have to read this data set. So what we will do is, I will say inside a pandas module, we have a inbuilt function, which is a CSV, because this is a CSV data set. You can see it is a .csv format data, which is a comma separated values data. Now I will say over here, I have to just paste this path. Then I'm going to say, this is exactly my data set that we have to read over here. So I will say, let me just paste all these things. Let me just say, this is exactly that data set that we have to read. Let me just copy and let me just paste this entire file over here. And one more thing that you can often do over here, you can append this R that stands for raw string that helps Python. Yeah, this is exactly the entire path and this is exactly the entire file that you have to read. Now if I will execute this line of code, now you will see it will exactly return your data frame, and you will see it has probably 1000 observations along with 17 columns, and from this entire data you have to end up having some meaningful insights, some meaningful conclusion. So what I will do is I will say, why not store this data frame somewhere else, because we have to perform lots of data analysis. So I will say, let me just store it in sales and let me execute. And if I want to visualize, let's say first 5 rows, so I will just call this head function. That's not rocket science. So if I will execute it, you will see these are my first 5 rows, of course, from my sales data frame. And to cross check all the column data types, what you can do is I will say sales.dtypes. We have an inbuilt property inside this data frame. So if I will execute, you will see, of course, all the features and their data type, of course, assigned over there. Now what we have to do, you have to do several data manipulation wherever it is needed. So the very first assignment is we have to perform data pre-processing, of course, on this sales data frame. So from this entire data, you will figure out my date features. Unfortunately, it supports object category. But from basic knowledge, we all knows it must support something known as DateTime functionality. It must support this format. So what I will do is, I will do some basic data manipulation on top of this, of course, on top of this date feature, as well as on top of this time feature as well. We will manipulate both the features and we will end up having our data in the form of DateTime property or in DateTime nature. Because unfortunately, pandas assign all the DateTime features in the format of course, object. As if you will see, imagine date follows, let's say, some kind of, let's say dd slash, let's say mm, let's say, and yy. Let's say this is the trend that my date, of course, follows. So from basic common knowledge, we know how this format can be of a string nature. Imagine this is my date, let's say 22, let's say 08, let's say 2014. So from basic domain knowledge or from basic knowledge, how can this, of course, belong to my string class? So anyhow, we have to convert this into DateTime nature so that it follows a timestamp functionality. Because once this follows this timestamp functionality, we can easily fetch some of the derived attributes from this data. We can easily fetch this. That's not a rocket science. So I'm going to say, let's say sales of, let's say very first we have to access this date feature. So I'm going to say sales of date. And let's say I'm going to access the data of 0th observation. And if I will execute, this is exactly my date. And on top of this, imagine if I will say what exactly its type. And let me just execute. You will see it belongs to a string class. Now we have to convert this string into timestamp nature. So what we will do is, I will say exactly from this pandas module, I have a amazing class which is exactly to_DateTime. So this is exactly that class that is responsible for converting your all the string values into timestamp values. So let me just execute this block of code. Now what I will do is, I will say, let me very first call this to_DateTime. Over there, I have to just mention the sales of date. Of course, you have to take care of all these typos. So I'm going to say it is exactly one date. Now once you will do this, you have to update this as well. So let me say I have to update by just basically assigning all this value. Now if I will execute these blocks of code, and let's say again I'm going to just copy it and again let me execute. Now you will see, of course, it belongs to timestamp nature. That's what I really want to show you. Similarly, if I will say sales of date dot dtype, now you will see it, of course, belongs to this format. In a similar way, you can also manipulate your time feature as well. So what I will do is, I will say, why not just manipulate your time feature? So I will say, let me just manipulate this time feature. Over there, what I will do is, I will say, I have to do some manipulation over there as well. Now, if I will execute, you will see all these steps are okay. And if I will say sales of, let's say, time, on top of this, just call this dtype over there to cross check whether all these steps have been happened or not. Let me just execute. You will see now it belongs to this DateTime functionality. So that's all about this session. In the upcoming session, what we will do is, we will fetch some derived attributes, of course, from this time feature and of course from this date feature. And of course, we will learn how to fetch derived attributes. And very first, we will learn what exactly are derived attributes. And we will also learn all the ways, of course, all the alternatives to fetch all these derived attributes from your date feature and from your time feature, of course. So that's all about this session. Hope you love this session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is, we have basically read our data, of course, just using this read CSV function, which is defined in my pandas module. Then we have performed several data manipulations on top of this date feature, as well as on top of this time feature, just to ensure whether they supports, of course, my DateTime functionality or not. So in this session, what we have to do is, we have to basically fetch derived attributes from data, of course, from this date feature and from time feature. So very first, let me show you one more thing. So I'm going to say, let's say sales of date. So very first, let me fix this, and this is exactly date. So you will see this is exactly my entire date. So from this entire date, you will figure out this is exactly my year, this is exactly my month, and the last one is exactly my day. So this one is my day, the second one is exactly my month, and the first one is of course my year. So this is exactly the hierarchy that we have to follow while fetching our derived attributes. These are exactly my derived attributes that I have derived, of course, from this date feature. So from this date feature, we can derive, hey, what is a year? And let's say what is a month? And let's say what is a day? So these are the things that I can derive, of course, from this date feature. In a similar way, from this time feature, I can derive, hey, can you tell me what is an hour? Or can you tell me what is a minute? In a similar way, I can access, hey, can you tell me what is a second? So these are all the derived attributes that I can fetch just from this time feature. Of course, if we have derived attributes, they helps a lot while performing some in-depth analysis. Let's say, what is an yearly gross income? What is a monthly gross income? So these are some of the amazing analysis that we can perform once we have these derived attributes. Now, what I will do is I will say, just define a function, and what this function will do, that function will return a day, month, and year for us. That's what my function will do. So I will say, just define a function. Let's say fetch underscore, let's say attribute. So over there, I have to just pass some x, or I have to just pass some observation. And on top of this observation, I will say, let's say x dot day. It will return me exactly my day. So I will just store it to, let's say, day. Now, on top of this, I will say x dot month. So it will exactly return me month. So I will say, just store this month. Then I will say, on top of this, just call, let's say, year. It will exactly return me year. So let me store this in year. Now I will say, just return, of course, what is my day, what is my month, and what is my year. So I will say, just return my day, then my month, and of course, what is my year? That's what I will do. So let me just execute these blocks of code. Now what I will do is I will say, of course, sales of date. On top of this date feature, I will say, I have to apply a function. So I will say dot apply. What we have to apply? Of course, we have to apply this function, what we have to find. So if I will execute these blocks of code, now you will see it will return all these values. Of course, from first observation, it will say, my day is 5, my month is 1, and my year is 2019. That's what this will return us. Now we have to store all these values, of course, in my data frame. Now again, if you want to insert all these values in data frame, very first you have to convert this into series data structure. So what I will do is I will say pd.series, because it will exactly return me my series. Now I will say just execute, and if again I will execute these blocks of code. Now you will see, now you have values in the form of series. Now what you can do is you can store all these values in your data frame. So I will say I have to store all these values, of course. So for this, very first we have to define a column. So the very first, this is my 5. So to store this 5, I will say this is exactly my day. Now to store 1, I will say this is exactly my month. And to store, of course, this 2019, I will say this is exactly my year. Now what we have to do, we have to just execute these blocks of code. And if I'm going to say, let's say sales.head to showcase my very first 5 values. Now you will see the 3 columns which are exactly my day, my month, and my year gets inserted into your sales data frame. Now let's talk about all the alternatives that we can think of apart from what we have discussed over there. So this is the first way, what we have discussed. The second way is we will define each function for each of the tasks. Let's say to extract day, I will define one function. To extract month, I will define one function. To extract year, I will define one more function. And then I will apply on top of this date feature, and then I will store all the values. This is the first way. The second way is one of the optimal way. This is exactly the second way. This is exactly, of course, using my lambda. So I will say using this lambda, we can of course fetch all the derived attributes. This is the second way, and we will discuss it in just in a while. The third way is exactly my DateTime module. So first is very simple. We will just define some function and just apply on top of this date feature. That's it. That's all about our very first approach. The second is, which is exactly my lambda approach, what we will do over here is, instead of defining this function and then applying this function over here, we will say, using this lambda approach, we will directly apply this function just using this lambda, of course, inside this apply. So in nutshell, what this lambda is all about, this is a optimal way of applying a function, of course, not just applying, of course, of defining a function and applying a function on top of any feature you have. That's what my lambda will do. The third way, which is my DateTime module, using this DateTime module, we have some inbuilt function that we will call, and then we will end up having our final output. That's what, these are all the three ways that I will discuss over here. So I will say, let's say we have to access a day from this date feature. So what I will do is, I will say sales of, very first we have to access, of course, my date feature. So I will say this is my date feature. Now I will say dot apply. Now I will say lambda of x. It means on each and every x, or you can say on each and every observation, I will just call this x dot day. That's a very layman explanation of applying a lambda on top of your feature. And if I will execute this blocks of code, it will exactly return me my all the days. So in nutshell, what we will do is, we will just define a function and then we will apply on top of my date feature. But using lambda, we don't have to define a function. We can directly apply that function on top of any feature that you have inside your data frame. Of course, this is the optimal way, and in the real world, it is one of the extremely used ways. In a similar way, we have some more alternative, let's say, using DateTime module. So what I will do is, I will say on top of this date feature, I will say dot dt dot day. And if I will execute, now you will end up having all the days. Now you will see we have three approach to do the similar task. Again, depending upon the need, you have to use that approach. But one of the most optimal way is, you can think of using this lambda approach. That's what you can often use in the real world. Similarly, for month, you have a function which is a month, and these are all the values of month. Similarly, for year, you have a function, inbuilt function, which is exactly year, and these are all the values of the year. That's not rocket science. Now what you have to do is, let me say I'm going to say sales dot columns, and if I will, let's say, execute it, now you will see you have all the values, or you can say all the columns in the form of list. Now from this, of course, from this time feature, you can extract all other derived attributes, of course. So let's access all the derived attributes. So I'm going to say, let's say sales of this time feature. Now on top of this, I will say just apply. Now what we have to apply? So I'm going to say, using this lambda, I can apply that function. So I'm going to say on this x, I'm going to say on top of this x, let's say we have to access, let's say, hour. So if I will execute, it will return all the hours. So let me store it somewhere else. So I will say, let's say sales of, let's say, hour. You have to define that feature to store all the values. Now let me just execute these blocks of code. So these are all the hours that I have inside my sales data frame. So if I will again execute these blocks of code, now you will see you have an hour feature that gets inserted in your sales data frame. In a similar way, if you really want to perform some of the advanced in-depth analysis, at that time you can access, let's say, hey, what is a minute? In a similar way, we can also fetch, of course, a minute and of course second as well. Imagine, let me show you one more thing. If I will say sales of, let's say, time, let me say it is this time, and if I will execute, these are all the observations that we have. Imagine you don't have any inbuilt function, let's say hour, or let's say any DateTime module, or let's say even you don't have any lambda. So in such case, what you have to do, again, you have to use some other approach. So let me show you how you can do that. So let's say I'm going to access data of, let's say, 0th observation. So this is exactly the entire observation that we have. So from this is exactly my, of course, this is my hour that we have to access. So on top of this, if I will call, let's say, split, or you can say just split it, and let me pass what exactly is a separator. So I will say just split it on the basis of this space separator. And if I will execute, now you will see you have a attribute error. So what this error is all about? So it says whatever data you have, that is exactly, of course, from timestamp nature. So timestamp object doesn't have any inbuilt attribute split, because this split attribute is defined for a string nature. Let me show you that. So if I will say, let's say, and let me execute, and let me just copy this one. So I will say this is exactly my string. Let me cross check that. Let me show you how to cross check it. So on top of this, if I will call, let's say, what exactly its data type, you will see right now it supports, of course, my string nature. Now what I will do is I will say on top of this, if I will call, let's say, split, and I will say just split it on the basis of this space separator, and let me just execute. Now you will see it will return my values in the form of list. So this is exactly my 0th index data, and this is exactly my first index data. Now I will say I have to access first index data. Let me execute. Now you will see you have the entire time over here. This is my hour, this is my minute, and this is my second. Now on top of this, I will say I have to again split this string, and I need values in the form of list. So I can again call split. This time my separator is, of course, this one. And again, if I will execute, you will get all the values over here. Now you have to access this 13. So I will say just access data of 0th index. Now you will see this is a value that you really need. But there is a hack over there. You will see this is a value that supports string nature. But we know whatever hour we will get, it must be of integer format. So for this, we have to convert this into integer format. So I will say just call this inbuilt int on top of this 13 so that it will get converted into integer format. And if I will execute, now you will see right now this supports a integer format. But again, imagine we have, let's say we have different formats in a same feature. Let's say we have one more format. Let's say over here you will see this is my, of course, date, and this is entirely my time. Imagine I have a format. Let's say very first we have some time, and then let's say we have some date. Let's say we have this format. So in such case, if I will use this code, whatever I have written over here, this would not work if I have this one scenario. So in short, if we have different types of formats of time in a similar feature, then this approach will not be handy over there. Then in such scenarios, you can think of using this lambda, defining one function, converting to DateTime functionality. So these are all the ways how you can actually extract all the derived attributes. So these are all the ways, whatever we have learned. So if you guys have any issues while learning this, feel free to ask us in the Q&A of the course. Just post your query and just ask your doubts. So that's all about this session. Hope you loved the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is we have extracted some of the derived attributes, especially from my date feature and of course from my time feature. Now in this session what we have to do is we have to perform something known as descriptive analysis on top of course, on our sales data frame. So to perform descriptive analysis, we have to just call this inbuilt describe function. So I will say on top of this describe function, if I will press, let's say, shift plus tab over there, now what it will return us basically, it generate our descriptive statistics, and these are all the custom parameters that you can play with that. Now if I will, let's say if I will execute these blocks of code, now you will see these are all the stats over here. Let's say I have to transpose this matrix. So on top of this, I will say just call transpose. Let me again execute. And these are some of the amazing statistics that you really need to know about your data. So from this entire statistics, you will see we have all these observations. Of course, these are not my observations. These are especially my columns of my data frame. Let's say what is the unit price, what is the quantity, tax 5%, total, and all these features. And these are some of the statistics that we really need to understand. This is exactly the count, or you can say total number of the observations. This is the average of a unit price. This is the average of a quantity. This is the average of a tax 5%. These are all the statistics. This is of course my standard deviation. this is my minimum value. So minimum unit price is 10.08. This is my 25th percentile data. This is my 50th percentile data. And I will explain just in a while what all about this percentile. This is my 75th percentile data and this is my maximum value. So this 25th percentile, what exactly it stands for? What stands for this 25th percentile? It stands for, there are total 25% of data that are below than this value. It means in case of unit price feature, there are 25% of data that are below than 32.87, and of course 75% of data that are greater than 32.87, and of course this is my 75 percentile data, and of course in case of less than, we have 25 percentile data. This is what this 25th percentile stands for. Similarly, we have 50th percentile, which is often known as median, which simply says half of the total data is below than this and half of the total data is above than this. That's what my median stands for. In a similar way, we have this 75th percentile data and a maximum value as well. This 25th percentile is often known as first quartile. This is often known as first quartile. This 50th percentile is often known as second quartile, and this is exactly known as third quartile. In a similar way, you can also perform something known as correlation analysis. So for this, what you really need is, I will say sales dot correlation, and if I will press shift plus tab, so these are all the things that will return us. So what it will basically compute, it will compute, of course, pairwise correlation of the columns excluding null values. It will automatically exclude all the null values from my data frame. And internally, it uses a concept, something known as Pearson correlation, just to return all the correlation values. And if I will execute, now you will see it will return us this amazing correlation matrix. Let me tell you what all these values stands for. But before explaining you, let me make it more user friendly. So what I will do is, I will say, let's say I will round all the values. So for this, I'm going to say numpy dot round. Let me round it, let's say up to 2 decimal places, and let me again execute. So these are exactly my all the correlation values. Now to make this matrix more user friendly, what you can do, you can create its heat map. So I'm going to say inside this seaborn, I have amazing heat map, and this heat map is all about, it will provide us our color encoded matrix. Now if I will execute, now you will see over here, it will exactly return me this matrix like this. Now to showcase your value, you have to use a parameter which is a anot parameter, and let me assign its value as true. Let me again execute, and this is the amazing heat map for what we all are waiting for. Now you will see your values are getting overlapped. So to get this issue, what you guys can do is, I'm going to say plt.figure. We are just going to increase our figure size so that we can get a bigger picture of this visualization. So I will say, of course, I can manipulate my figure size. Over there, let's say my figure size this time is, let's say 14,8. Let me just execute these blocks of code again. And this is the amazing visualization for which we all guys are waiting for. Now you will see between unit price and of course unit price, we have a correlation of 1 because both are same features. Even if we plot its histogram, that makes no sense because both features are same. Similarly, you will see, let me explain you that. So you have a value, let's say 0.63. It means between unit price and of course tax 5%, we have a correlation of 0.63. It means if unit price increases, there is a 63% probability that my tax 5% also increases. That's a very layman explanation of this correlation. And inside this correlation matrix, in a diagonal nature, I will get all the values as 1 because these are nothing but these are my same features, and it makes no sense. That's why the diagonal values are 1. It makes no sense. Again, between gross income of course, and between this tax 5%, we have a correlation of 1. So what exactly it means? It means if my gross income increases, there is a 100% probability that tax 5% also increases by same factor. Similarly, we have a pretty high correlation between gross income and of course between this total feature. Similarly, we have pretty high correlation between this cost of goods feature, between tax 5% and of course between this total features. And of course the total feature and of course this cost of goods. So these are some of the features where we have slightly higher correlation, approx close to 1. So in statistics, correlation has basically two categories. It will be either negative or it will be either positive. Correlation having 0 makes no sense. So if it is negative, imagine if it is negative. So negative basically means, imagine a correlation is negative between, let's say, tax 5% and let's say total. So it means if tax 5% increases, let's say its correlation is let's say point minus 0.71. Let's say this is the correlation value. So it basically means if tax 5% increases, then there is a 71% probability that total feature gets decreases by a same factor. Similarly, if its correlation value is plus 0.71, then it basically means if one feature increases, other feature also increases by a same factor. So if we have a correlation of 1, what exactly it means? It means if x increases by, let's say, 1 unit, in a similar way, y also increases by a 1 unit. It means its slope is 1. It means its slope is 1 because from y equals to mx plus c, typically from the basic mathematics that we often learn in our high school days, that is exactly a formula of a straight line. So over there, where my c is my intercept and m is exactly my slope. So if my slope is 1, then x equals to y. And this is what it is. So if my correlation is 1, that simply means my slope is 1. It means my theta will be 45 degree. So let's try to cross check all these things whether we have a slope of 1 or not over here. So I will say, I'm just going to call a scatter plot function. You can also think of using regression plot. That's not rocket science. So I'm going to say it is exactly a scatter plot over there. Inside this x, I have to basically mention my tax 5%, which is my feature, because between two features we have a correlation of 1. So I will say this is my tax 5%. Then of course on y-axis I have one more feature, which is exactly my tax income. Now we have to mention what is exactly my data frame. So I am going to say data is exactly my sales. Now let me just execute this blocks of code. Now you will see you have basically a straight line over there. It means you have a slope of 1. It means you have a correlation as, of course, 1. In a similar way, you can see between, let's say between quantity and let's say cost of good feature, because these are some of my important features. So you have a correlation as 0.71. So let me just visualize all these things. So what I will do is I will say this time on x-axis the feature that we have is exactly my, let's say, quantity. So I will say this is my quantity. Then on y-axis we have a feature which is, let's say, costs. And let's say we have to customize our visualization as well. So I will say, let's say this time I have to assign, let's say, green color data points. Let me just execute this blocks of code. Now you will see you have this kind of data points that are scattered over here. So if you want some kind of relationship or regression plot, you can think of using regression plot. So I will say instead of using scatter plot, I can use my regression plot. So let me just execute this blocks of code. Now over here, probably you will see a straight line. And of course that has a slope of 0.71. So that's all about the session. In the upcoming session, what we are going to do is we are basically going to perform analysis on our city feature, of course, what is the mean rating, and we will try to visualize all these things. So that's all about this session. I hope you will love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, since we performed some of the statistical analysis, some correlation analysis, and we have fetched all the derived attributes that we often need in this entire use case. We have done all these things. So let's go slightly ahead and understand all the data pretty well. So the very first problem statement in this assignment is we have to find some kind of relationship inside my data. So this is exactly my very first problem statement. Let's say we have to find, hey, can you tell me what is the relationship between my tax 5% feature and let's say total feature. Let's say these are the two features that I'm going to pick from here, and especially I'm going to find some kind of relationship between both the features. So if we have such scenario, we can pick up this scatter plot and we can plot all the necessary stuffs. So what I will do is I will say just use the blocks of code and just do some basic manipulation over here. Here we have tax 5% and here we have total feature. So here basically I will say my feature is nothing but exactly my total. And if I will execute this cell, now you will see you have a straight line. And of course, in this statistical analysis, you can observe, of course, between total and between this tax 5%, if you will see, we have a correlation of 1. It means if tax 5% increases, this total feature also increases, or total sales also increases in a same factor. So let's try to move toward the second problem statement. That's all about, of course, which city has more gross income. Now let me show you that. So if I'm going to say, let's say sales of, let me very first access this city feature. Now you will see you have all the cities. Now on top of this, if I will call, let's say, hey, can you return me the unique number of cities, or can you return me all the unique cities inside the city feature? And if I will execute, you will get a list or an array where you have all the unique cities. Of course, these are my 3 unique cities, and with respect to 3 unique cities, we have to find which city has more gross income. So to do this operation, we have basically 2 ways. The very first way is exactly using our filter approach, where we will try to provide a filter. Let's say inside this city feature, I will very first provide a filter wherever my city is young on. Just compute a mean of, or just compute a median of the gross income. This is my very first approach. The second approach, of course, this is my baby approach. This approach will not be handy if we have, let's say 20 unique cities, or let's say 50 unique cities. Of course, in the real world, you can have more numbers. So that approach will not be handy. Again, the second approach, you can think of using your group by. So using group by, you can do this operation very efficiently, because what this group by will return us, it will basically create a group. If I will call group by on top of the city feature, it will create a group of all the cities. So once we have a group by, I can say, hey, just compute a median of the gross income. Again, the question is, why median? Again, this is one of the important aspect that you have to understand. Why median? Why not mean? Why not mean of the gross income in such scenarios? Again, if you have the outliers in data, always think of using this median, because median will not get affected by outlier, because median is nothing but my 50th percentile. It is nothing but my 50th percentile, or you can say it is exactly my middle observation. It is exactly my middle observation. But if, let's say if I will compute, let's say mean. So in such case, imagine inside this gross income feature, we have some, let's say we have some low values, and let's say we have some pretty high values, and we have some range of values over there. So if we have such kind of distribution available inside this gross income feature, in such case, my mean will get fluctuated. That's why if we have a skewness available in any feature, in such case, you can think of using this median instead of this mean. That's a simple explanation behind all these stuff. So I will say basically sales dot group by. Over there, I will say just create a groups, of course, in city features. Then I will say just access my gross income feature. So once I will access it, then I will say on top of this, I will say just compute its median. That's it. And if I will execute this line of code, you will see, of course, this Mendeley has of course that much median, you can say, and Yangon has that much, and all these things. Again, imagine this is a real world data. Imagine you have, let's say, 100 cities. So in such case, just a single block of code will return all these stats. You don't have to write a filter and just to write code manually. So our next problem is all about, you have to find your mean rating and you have to visualize it as well, of course, on the distribution of your mean. So what you can do is, let's say very first you have to visualize what exactly is the distribution of my rating feature. So I'm going to say SNS dot distribution plot over there. If I will press shift plus tab, that's all about the signature of my function. Here we have tons of parameters that we can play with that, and these are all the things. So what I will do is, I will say sales is exactly my data frame. Over there, I'm just going to, let's say, access my rating feature. And if I will execute, of course, you will see you have all the warnings just because of the depreciation. You will see this is exactly a kind of distribution you have in your rating feature. Now, if you need your histogram instead of such kind of distribution, what you guys can do is, you can pass a parameter which is a KDE, that is exactly kernel density estimation, and you can set its value as false, because by default it is set as true. And again, if I will execute, now you will get data in the form of course, histogram. Now, on top of this histogram, I can showcase my, let's say, hey, can you plot, let's say, can you plot what exactly the mean rating or a median rating, whatever you want, it's all up to you. So what I will do is, I will say, very first, let me find what exactly is the mean rating. So what I will do is, I will say, sales of rating. Of course, this is in cap form, and on top of this, if I will say, hey, can you return me what exactly it's mean, and if I will execute, this will return me a mean. Again, if you want to do it using numpy, you can do it as well. So I will say basically numpy dot mean over, let me pass all these things, and if I will execute, you will see you have a similar mean over here. Now what you need to do is, you have to showcase this mean on top of this histogram. So what you guys can do is, I will say, of course, plt dot, we have an inbuilt function which is a axis vertical line, which is exactly available in my matplotlib. So if I will press, let's say, tab over there, you will get all these functions. So this is exactly that function of which I am talking about. You will see you have all these things over here that you have to pass. What it will do is, it will basically add a vertical line across the axis, whatever axis you have or whatever visualization you have. Now what I will do is, I will say on X, I will just mention all these values. Of course, if you want to provide your own color of the line, you can use this color parameter. So I will say inside the C, let's say I want to showcase, let's say, in the form of red color, whatever you want. And let's say you want to assign some label as well. So I will say, let's say label is exactly average rating. And if I will execute this line of code, now you will see this is exactly your mean rating, and this is all about your histogram. In a similar way, you can showcase your median as well, or in a similar way, you can showcase your 5-point summary. That exactly holds my 25th percentile data, my minimum value, my 50th percentile data, my 75th percentile data, and of course my maximum value. So that's all about this session. In the upcoming session, what we are going to do is, we will try to define some custom functions that will help us and of course that will smoothen our task to perform some in-depth analysis. That's what we will do in the upcoming session. So that's all about this session. Hope you love this session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session what we have done is, we have performed some of the basic analysis as well as some of the relationship inside data, as well as we find what exactly is the mean of the rating and how to visualize it on top of your distribution of your rating. That's what we have done, especially in the previous session. So in this session, what you have to do is, your problem statement is all about, you have to define own custom functions that will help us to perform some of the in-depth analysis that helps us to understand data pretty well. That's what we have to do in this session. But very first, let's understand what exactly is the use of defining a custom function. Let's say you have to analyze, let's say, hey, can you return me, let's say, hey, can you return me what is the label distribution of, let's say, gender feature? Or let's say, hey, can you return me what exactly is the distribution of, let's say, payment. Let's say I just need a distribution of, let's say, hey, can you return me what exactly the distribution of label distribution of city feature? So these are all the features. Let's say you need a label distribution of all these. So what you will do is you will call a count plot function, of course, that is available inside a Seaborn module, and you will call this function thrice just to get a meaningful conclusion. Of course, you will pass some parameters over there and you will end up having our conclusion. That's what you will do over here. But if you will define your own custom function, you don't have to again call this again and again call from the C1 module. So why not just define a function? Why not just define a function and just write some blocks of code? And if there is a need, I will say, hey, just call this count plot. And let's say, just pass this feature, let's say gender feature. And what this will do is, this will basically return me my label distribution. That's what I will do. In a similar way, let's say I just need a trend of some features. Let's say I just need a trend of my total sales feature or my gross income feature. Let's say I just need a trend of all these features. So if I need trend, I will call my line plot function just to need a trend from, of course, from my matplotlib or from my Seaborn. That's not an issue. We have tons of library just to call this line plot. So instead of calling this line plot again and again, why not just define some function and write these blocks of code inside this function, and if there is a need, just call this function. Of course, this is a very handy approach. Again, writing similar lines of code again and again makes no sense in the real world. That's why the optimal way is just define a function or just define a class, and inside that class define multiple functions. That's how your entire library, whether it is NumPy, whether it is pandas, or whether it is scikit-learn, whatever library it will be, whether it's a machine learning library, whether it's a deep learning, whether it's a computer vision, or whether it's a time series analysis, whatever library it will be, internally they all use this concept. They use basically my basic OOPS concept just to perform all these things internally. So let's try to define very first all the custom functions that you exactly need. So very first, let's define a function, let's say with respect to count plot. So what I will do is I will say, or let's say its function name is, let's say return underscore count underscore plot, whatever name you want to assign. Over there, what I will do is I will say whatever column name I will pass to this function, whatever column name I will pass, it will exactly return me a count plot. Let me show you the entire documentation of this count plot. So what I will do is I will say sns.count plot. Over here, if I will press shift plus tab, that's all about my documentation. Here we have an important parameter, which is a hue parameter. So what this will do is, it will basically split my graph, or you can say, it will basically split my distribution into total number of unique features in a column. Let me explain all these things. Imagine in gender feature, we have, let's say, male and female. And let's say female has, let's say, 400 or 200 entries or observation. Let's say male has, let's say, 800 observation. And let's say I need a label distribution of this gender feature. So what I will do is I will say, just call a count plot, of course, just call a count plot. And in this, if I will pass a hue as gender, so it will exactly return me this, let's say, this is with respect to male, and this is with respect to female. That's what my hue will do in a nutshell. So now what I'm going to do is I'm going to say it will exactly return me exactly this count plot. Over there I have to just pass some parameters. So the very first is whatever column I will pass to this, of course, to this count plot. Then of course what is my data frame, which is exactly my sales. Then what is my hue? So whatever hue name I will pass to this count plot, it will return me exactly my level distribution, and I will receive the value of this hue name exactly from my return underscore count plot function, and by default its value will be none. And if I will pass the value of the hue name, it will exactly return me my label distribution. That's what this function will do for us. Let me just execute these blocks of code, and again let me define some more function. Let's say with respect to, let's say, box plot. So what I will do is I will say return underscore box plot. Very first, let's say what I will say is what we have to do is I'm going to say SNS dot box plot, and that's all about my documentation of this function, where we have tons of parameters that you can play with that. So on x-axis you have to pass some feature, on y-axis you have to pass some feature, and then you have some hue parameter, and then you have some data parameter. So what I will do is I will say x equals to, let's say, x underscore column, and I will receive this x underscore column, of course, while calling my function, and y is equals to y underscore column. Now what I will do is I will say this is exactly x underscore column, whatever I will pass over there, then it is exactly y underscore column, whatever I will pass over there. And of course I have to pass what exactly is my data frame, and I'm going to say data is exactly, of course, my sales data frame. Let me just execute these blocks of code. In a similar way, what I will do is I will define one more function, which is exactly my line plot. So I'm going to say this is exactly my line plot function. Over there we have to pass just some parameter. So the parameter that we exactly have to pass this time is a similar one what we have passed earlier. So these are all the parameters that we have to pass. Again, over here we have to just copy the code, and we have to just do some basic data manipulation. So the function that we have to pass is exactly my line plot, and if I will press shift plus tab, that's basically your signature, all the parameters that you have and all these things. That's not a rocket science. Now what you have to do is, here you have to pass just some features on x-axis, some features on your y-axis, and what exactly is the data frame. Now we have to just execute these blocks of code. Again, if you want to define some more custom functions, you can define it. It's all up to you. Let's say we have to define some more function. Let's say what is a relation plot. But before defining a function for this relation plot, let me explain you one thing. Let's say you have to analyze, let's say, how much sales occurs in, let's say you have to analyze how much sales occurs in each and every branch, of course, how much sales occurs in each and every branch with respect to each and every month. Let's say this is the problem statement that you have to solve. Again, this is slightly more complex problem statement what we have solved till. So from this problem statement, if you will figure out, depending upon the number of subcategories in this branch feature and in this month feature, it will exactly create a matrix for us. Imagine we have two branches, let's say A and B, and imagine we have 2 months, let's say March and of course let's say April. Let's say we have 2 months, and of course we have some sales, or let's say we have some feature, let's say hour, and let's say sales or quantity, whatever you want to mention. Let's say these are my two features, and let's say we have to analyze all these things. So what we can do is we can just create a matrix, or you can say, very first I will just add a condition as if my branch is A and my month is March. And the second scenario, my branch is A and my month is, of course, April. This is the very first scenario. And we will simply plot, of course, on x-axis we have just an hour, and on y-axis we can simply put up a quantity. Similarly, over here we can simply do this. In a similar way, I will say the third case will be my branch is B, and of course my month is March, and my branch is B and my month is April. So these are the 4 cases that just this problem statement will create. So to end up having such conclusion, we have basically two ways. The very first way is you can just create a filter over there, and you can just put a filter as wherever my branch is, let's say wherever my branch equals to A and my month equals to, of course, my March. And this is my, let's say this is my condition, or you can say this is my filter. So I will just pass this condition inside my sales data frame, and I will end up having my final data frame. And then I will simply plot the, of course, plot line plot between hour and quantity. This is the first way. Of course, we have to just write it, of course, 4 times, because we have 2 categories inside this branch and 2 categories inside this month. So of course, writing multiple lines of code just to end up having some meaningful conclusion will not make sense in the real world, because over there you have to write a optimal code. So if you have such scenario, you can think of using this relation plot. So what this relation plot will do us for, it will just generate such kind of scenario. It will just generate such kind of scenario for us. So we have an inbuilt function, of course, in Seaborn, and we will just pass some parameter and it will generate a relation plot for us. So in the upcoming session, what we will do is we will just define a function for this relation plot, as well as we will perform some of the in-depth analysis depending upon whatever functions we have defined over there. Considering all these functions, we will perform slightly better analysis just to end up having meaningful conclusions. That's what we will do in the upcoming session. So that's all about this session. Hope you love this session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is we have basically defined some custom functions so that we will perform some of the amazing analysis. And of course, we have learned what is a relation plot and when to use a relation plot. So let's try to define a function especially for relation plot. Again, this is a relation plot function which is exactly available inside my Seaborn module. You will see we have a function which is this rel plot, and of course if I will press shift plus tab, you can check out all the signature of this function, what all parameters it have, and what it will return us. It will return us basically a figure level interface for drawing a relation plot, or you can say onto a facet grid, that is often known as your matrix. So over here we have some important parameter which is my x, of course, which is my y, and how to create a facet grid or how to create a matrix, you can say using 2 features which are exactly my, let me show you where we have, that are exactly my row and of course that are exactly my column. And if you want to assign some hue name, we have a parameter, let me show you where exactly it is, and this is exactly my hue parameter. And if you want to assign some kind of styling, we have of course my style parameter, and of course we have some kind parameter. So depending upon the need, we can use all these parameters. If you want to assign some own size, we can think of using the size parameter. So now what we will do is we will use this relation plot function and we will write some lines of code. So I will say define, let's say return underscore relation plot. So I will say relation underscore plot. Over there I will pass some parameters, of course. So the very first thing that I will pass is exactly inside this relation plot is, let's say x equals to x underscore column. Then inside y, I will mention y underscore column, and I will receive its value, of course, from my function. So I will say x underscore column, then y underscore column. Then we have to pass, let's say what is a column? Of course, what is a column? So I will say my column is nothing but my column underscore name. Then I have some row. So I'm going to say row underscore name. Then of course I have some, let's say I want to assign some own kind. So for this I can play with this kind parameter. This is exactly my kind. Over there I can say relation underscore type, whatever type I will mention over there. Then over there I have to receive all these values. Of course my values are column name, my row name, and my relation type. So I will say I will receive a value of column underscore name from my function. Then I will receive a value from my row underscore name from my function. Then I will receive a value of relation type from my function. That's what I will do. Then we have some more thing. Of course, let's say what is a hue? So I will say hue is equal to hue underscore name, and I will receive its value from my function. And of course style as well. So I will say style equals to style underscore name, and last one is exactly, let's say data, on what data you have to perform all these operations. Then I will receive a value. Of course, this is my hue name. Then I have a style underscore name. And if you want to assign some default value, so I will say let's assign none. In a similar way, inside this hue name, I will assign just none. In a similar way, if you want to assign some values to this relation type, you can assign some none values. In a similar way, you can assign this none, of course, to my row name and of course to my column name. That's what I will do. Or to make all these things more user friendly, you can just assign some kind of spacing. So I will say just assign proper spacing, again proper spacing, and again proper spacing. Similarly over here, assign proper spacing, similarly over here, similarly over here, similarly over here, similarly over here, of course not this one, similarly over here and similarly over here, so that your code does not look messy. Now what I will do is, I will say whatever relation plot it will return us, I have to just return it. That's it. I will say just use return. Let me just execute these blocks of code. So the very first problem statement is all about you have to analyze a distribution of various branches. So if you will encounter to find a distribution in the real world, you have basically two approaches. Of course, you have two approaches. The very first one is you can use something known as distribution plot just to end up having a distribution. The second one is you can use your box plot. Again, box plot have its own advantage. Imagine if you want to perform some descriptive statistics along with distribution. In such case, box plot will be very handy for you. Imagine, let's imagine along with the distribution, you have to find what is the minimum value, or let's say what is the 25th percentile data, or what is the 50th percentile, what is the 75th percentile, or what is the maximum value. Or in a nutshell, you can say what is a 5-point summary of your data. What is a 5-point summary of your data? So if you have such scenario, in such case, you can think of using this box plot. Otherwise, it is good to use this distribution plot. Then what I will say is, I will say just call a function which is a return underscore box plot. What exactly we have defined over there? The very first parameter that I will pass is exactly my branch. The second is exactly my rating. And if I will execute this line of code, now you will see in this box plot, this is exactly my minimum value. This is exactly my 25th percentile. This is my 50th percentile, or often known as median. This is exactly 75th percentile, and this is my maximum value. And this is nothing but my 5-point summary, that is often known as 5-point summary in statistics. Again, this entire box is also known as IQR. That is my nothing but interquartile range. That is nothing but my Q3 minus Q1. Because see, this is my third quartile, which is known as Q3. This is my first quartile or a lower quartile, that is often known as Q1. So this box is often known as my IQR, which is my interquartile range, which is exactly my Q3 minus Q1, where Q3 is upper quartile or 75th percentile data, and this is my lower quartile or 25th percentile data. So from this box plot, we can end up having this conclusion here. Of course, this branch B has the lowest rating, because you will see it has a rating approx close to 5 point something, approx close to, and of course in case of A and B we have approx close to 5.7 or 5.8, but in case of B we have the lowest rating. That's a very simple explanation of this box plot what we have. So our second problem statement is all about, we have to analyze, of course, the trend of the sales. So if we have a trend, we can think of using our line plot function what we have defined. So inside this line plot, I will say the very first is exactly my hour. The second feature is exactly my quantity. And if I will execute this line of code, you will end up having your final conclusion. But you will see you have an error as a value error. Let's try to read the error why we are getting this error. Now you will see you have an error that says, hey, You could not interpret value hour for the parameter x what you have passed inside a function. So if I will see in this line plot function, we have passed in this x, whatever x column I will receive from my function. Now let me check what exactly a data type of this hour. So what I will say is, I will say sales dot dtypes, and if I will execute this line of code, now you will see, of course, this is my hour. Now this error is exactly on account of the typo that we are doing over here. Let me show you that. So if I will execute this line of code, now you will see this is right now executing, and you will just end up having this amazing trend. So that error was exactly due to the typo that you are doing, because there is no such column available as what we have passed over here. Now from this trend, we can simply come up with this conclusion here. Of course, most of the stocks or most of the items, of course, are sold at, of course, this 14 hours local time. You can see over here we have a peak. So we can simply come up with this conclusion. So let's try to continue with our next problem statement. That's all about how much sales occurs in each and every branch with respect to each and every month. That's what we have solved exactly in the last session. Of course, using relation plot, it makes a lot of sense. But imagine if there is no relation plot, you can think of defining some custom filter and applying on top of your data. But again, if you have the relation plot, you can think of using that. So what we will do is, we will just call this a return underscore relation plot function. Over there, we have to just pass some of the parameters value. So I will say inside this x underscore column, I will just pass, of course, my hour. Let me show you one more thing. I'm going to say sales dot columns, so that we do not have any typo what we have performed, especially in the last analysis. You will see these are all my column name. Now what we will do is, we will say inside this y underscore column, what we will pass, of course, my quantity, and this is exactly my quantity. I will say this is exactly my quantity. Now after doing this, what I will say is, I will say inside this column underscore name, we have to basically pass our month. So I'm going to say it is my month. Then inside this row underscore name, we have to basically pass our branch. So I will say this is exactly that branch. Now let's say I just need a, let's say, line plot inside this relation, then I can mention that. So I will say this is exactly my, let's say, line plot. Then of course, let's say I want to split my relation plot or my line plot considering my gender feature. So what I will do is, I will say just pass just gender as hue name. So I will say this is my gender feature. Now once I will do all these things, we have one more parameter that we can take care of that, which is my style name. And over there we can say, hey, why not provide a styling? Of course, considering this gender parameter. So I will say style name is equals to gender. And if I will execute this line of code, it will just return some amazing relation plot just in a while. Now you will see this is exactly my relation plot. The very first plot is all about if you have a branch A and month 1, and this is exactly a line plot between my quantity and between my hour. Of course, this blue trend is exactly with respect to female, and this dotted line, this dotted orange line is with respect to male. Now you can simply end up having this conclusion. Yeah, of course, when we have a branch A and we have a first month, of course, it seems that in an initial hour of a day, female has an edge over there. You can simply end up having this conclusion. In a similar way, you can understand all other visuals and you can showcase all the meaningful insights. So that's all about this session. In the upcoming session, we will slightly go ahead and understand the data pretty well. So that's all about this session. Hope you love this. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is, we have performed some of the amazing analysis, as well as we have defined all the required functions that we really need to perform all the in-depth analysis, especially my relation plot function, what we have defined in the previous session. So in this session, what we have to do is, we have to perform some in-depth analysis. The very first one is, we have to analyze branch total sales per hour, of course, in each and every month. Again, In such scenarios, there we have basically two ways. The very first is your filter approach, and the second way is you can think of using your relation plot. So let's try to visualize it using relation plot. So what I will do is I will just call this function what we have defined, which is my relation plot. Over there, of course, on x-axis, I will say on x column, I will just pass, of course, my hour feature, because I need hourly in hourly fashion. And of course, on y underscore column, I will just mention my total, because total is all about my total sales, of course. Then I have one more feature, which is my column underscore name. Over there, I have to say it is exactly my month, because I need in a monthly fashion. Then I will say row underscore name, because we have several branches, so we have to create a matrix. For this, we have to use this row name. So I will say row name is all about my branch. Then I will say what type of relation I need. So I will say relation type is exactly my line plot. And if I will execute this line of code, so just in a while, you will end up having your amazing relation plot. So this is exactly your matrix, or you can say facet grid. So the very first analysis is where my branch is A and my month is first. And this is, of course, on x-axis we have hour, and on y-axis I have total sales. Or you can say this is the trend between hour and sales when we have branch A and we have month 1. In a similar way, we have all the trends available over there. Now you will see in month 3rd and branch B, of course, we have a spike, of course, in the evening hour. That's a meaningful conclusion with respect to my branch B and month 3rd. So let's try to go ahead and understand the next problem statement. That is all about, hey, let's see when customers buy certain products, of course, in all the various branches that you have. So in such scenarios, again, you can think of using this relation plot again. Let me show you how. In the problem statement, if you will figure out, you have a problem statement S. Hey, let's see when customer will think of buying all the certain products in the various branches. So imagine we have, let's say, 3 branches. Of course, in this data, we have branch A, B, C. And let's say we have, total products, let's say 10. So if I will use this relation plot, what it will give us? It will basically give us a matrix of 10 cross 3, where I have total 30 visualizations. The very first, the very second, the third till 10, and 11 till 20, of course, 21 and till 30. We have all the 30 visualizations over here, depending upon the number of products and the number of branches we have. And in each and every trend, or in each and every visualization, I will say just plot a trend, of course, between my hour and between my quantity. Just plot a trend between hour and quantity when we have a branch A and when we have a product A. That's a very layman explanation of this first plot. In a similar plot, we can plot all these things till the last visualization we have, and we will end up having some conclusion. That's what my relation plot will do. So I will say on this column name, I'm just going to say it is my nothing but my product line. Let me cross check that. So I will say sales dot columns. It will exactly return me my all the column names in the form of list. Now you will see you have a feature which is a product line. Now if I will execute this line of code, and just in a while you will get such an amazing relation plot. Again, this is a very massive visualization, because depending upon the total number of the products you have, and depending upon not a total number of products, depending upon the total number of the unique products you have, and depending upon the total number of unique branches you have, you may get a matrix like that. Now you will see probably you have a matrix of 3 cross 6, because you have 3 branches and you have total 6 unique products. Let me cross check that. So what I will say is, I will say sales of, very first you have to access this product line. On this I will say unique, just execute it. And on top of this, if I will say just compute its length. Now you will see you have total 6 unique products. And we know we have 3 unique branches, what we have analyzed, especially in the previous session. You will see we have 3 branches. That's why you will end up having a matrix of 3 cross 6. Now from these visualizations, you can see, of course, in home and lifestyle and in all the branches, of course, in the early evening, you can see a spike in home and lifestyle, product, and in all the branches, and of course in the evening time you can see a spike over there. In a similar way, you can perform something known as product analysis. So in such case, what you can do is let's say you can return what exactly its box plot with respect to, let's say, sales or quantity. So what I will do is I will just call a box plot over there. I will just mention, of course, what is my quantity feature, and then I will mention, of course, what is my product line feature. So I will say this is exactly my product and line feature. And if I will execute this line of code, you will end up having this amazing box plot. You will see from this box plot, health and beauty, electronic accessories, home and lifestyle, and sports and travel products have better median quantity, or even you can term it as average quantity, than my food and beverages, and of course from my fashion accessories. That's a simple conclusion behind this amazing box plot what you have fetched. Let's say you have to find which products get sold more. So in such case, I can think of using, of course, my count plot function. Over there, we have to just pass this product line, and I will just execute this line of code. You will see this is exactly your count plot. Let me assign my own figure size. So I will say plt.figure. Over there, I'm going to say this is my fig size, and I will just mention value, let's say 14, 10. And if I will execute this line of code, this is your amazing count plot. So from this amazing count plot, you will see, of course, your fashion accessories, which is exactly this one, is the highest, while health and beauty is the lowest. This is a simple, meaningful conclusion from this count plot visualization. That's all about this session. In the upcoming session, what we will do is we'll perform slightly better analysis. Let's say, hey, can you find the let's say relationship between, what is the relationship between gross income and product line? Or can you showcase, hey, how customers make payment in this entire supermarket sales business? Or what is the word cloud analysis? We will try to perform all these sort of analysis, and we will understand our data in a pretty good shape. That's what we will do in the upcoming session. So that's all about this session. And if you guys have any queries related to this session or related to all the previous session, feel free to drop us query in the Q&A of the course. So thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in the previous session, what we have done is we have performed some of the amazing relation plot between product line, branch, and some of the amazing box plot analysis, and we will end up having some meaningful insight. So in this session, the very first problem statement is all about, we have to find some relationship between, of course, my gross income and product line. So to do this analysis, you have basically 2 ways. The very first one is you can use your relation plot, and over there just pass some parameters and define. Let's say I need a scatter plot. This is the first way. You can use your own custom function just to end up having some conclusion. The second way is what you often use is you can call a scatter plot. Of course, both are pretty much similar. So second way is you can call a scatter plot just from some library, whether it will be Seaborn, whether it will be Plotly, or whether it will be Matplotlib. So I will say just call a scatter plot and just pass some features. And of course, my features are gross income and product line. So either you can think of using this one, or you can also prefer this one over this one. So basically, I'm going to say relation underscore plot. Of course, this is my return underscore relation underscore plot, which is the function what we have defined. Over there, very first I will mention this is my very first feature, which is exactly gross income. Then we have one more feature, which is exactly product line. So I will say this is exactly my product line. Now once I will mention all these things over there, very first we have to mention in this codes as well. Then I have to mention what type of relation I need. So I have a parameter which is a relation type. Over there I am going to mention this scatter. That's it. And if I will execute this line of code, you will get such an amazing relation plot, or you can say scatter plot. Now from this scatter plot, it is pretty much clear that persons who are going to buy the fashion accessories have a maximum gross income, because you will see over data point, and of course with respect to home and lifestyle product as well. So these are basically two domains where we have a maximum gross income. So our second problem statement is all about, hey, let's say we have to find how customers make payment in this market sales business. Again, depending upon the number of categories you have, let's say you have, let's say 5 options. Imagine you have 5 options. Let's say the very first is you can use your debit card, you can use your credit card, or you can use some e-wallet, let's say Paytm, PayPal, or any other wallet. Let's say Paytm and PayPal. Or you can use some other interfaces, let's say UPI. Let's say other platforms, let's say UPI. Let's say we have all these 4 platforms. Considering these 4 platforms, you have to find how customers make payment in this business. So if you have such scenario, you can think of using bar chart, or you can think of using this pie chart as well. So in nutshell, what we will do is we will say, hey, why not just plot a count plot? Because we have already defined a function with respect to this count plot. So what we will do is we will just plot its count plot. That's it. So let me do all these things. Let me do all these things over here. So I'm basically going to say, I have to just call a function which is a return underscore, of course, my count plot. Over there, we have to just mention very first is exactly my payment. Then let me press shift plus tab. You will see you have a column. Then you have a hue name. On what parameter you have to split your count plot. So I will say inside this hue underscore name, I will exactly mention my branch. And if I will execute this line of code, you will see this is your amazing count plot. Now you will see, let's say with respect to e-wallet, you will see branch A has a maximum transaction if I will talk with respect to electronic wallet. With respect to cash payment, of course, C is going to dominate. With respect to credit card payment, of course, there is some minor difference between all 3 branches. But again, A is going to dominate. This is a simple conclusion what we have fetched. So our last problem statement is, of course, does customer type influences our sales or not? So this is the problem statement that we have to analyze. So what we will do is, let's say we have 2 customer type. Let's say we have 2 customer type. Let's say customer 1 and let's say customer 2. So with respect to customer 1, what we really need to count is, we need to count the total sales generated by customer 1. Imagine it is X. Similarly, we need to count the total sales generated by Y. So if there is a huge difference between this X and Y, then in such case, I can say, of course, customer type, of course, influence the sales. But if this X and Y are approximately nearer to each other, in such case, I can say, no, they don't influence the sales. So that's why you have to analyze. That's what you have to analyze. So what you can do is, you can say, hey, why not just call a group Y? Again, there are tons of ways to do this, but again, this is one of the optimal way. The first way is you can think of using filter. Again, to do any analysis in almost 70% of the cases, this filter approach will definitely work. But again, try to use the optimal way. So what I will do is, I will say, just call a group by. Now once we have a group by, once we have this customer type, then I will say, just compute the summation of the sales. So what I will say is, just compute the summation of sales. Just compute the sum of the sale. So I'm going to say basically sales dot group by. Very first we have to create a group on the basis of exactly my customer type. So I'm going to say it is exactly my customer type feature. Then I will say I have to basically access my total feature. Now on top of this total feature, I will say just call a sum. And if I will execute this line of code, it will exactly return me all these states. Now you will see you don't have that much difference between a member customer type and a normal customer type. So I can say, yeah, definitely customer type don't influence the sale. Again, there is one more way to do this similar task. So what I will do is I will say, once we have this group by, now what I will do is I will say I can use something known as aggregation. I can use something known as aggregation. And if inside this aggregation, I can perform some operations, let's say minimum, median, and all these kind of operations. Of course, these are some of the basic operations. So what I will say is, I will say whatever operation you have to perform in the form of dictionary. So I can use this dictionary. Then I will say on top of course, my total feature, I will perform my sum operation. So I will say I will perform my sum operation. And if I will execute, you will see you will get all the results. Now again, there is just a basic difference between this and what you have extracted this. So whatever you have extracted over here, the results that you are getting, they are exactly in the form of data frame. Whereas this is exactly in the form of series. Let me show you that. And if I will say, let's say what exactly its type. And if I will execute, you will see it belongs to a series data structure of a pandas class. Whereas this one is exactly, of course, this is my data frame. This is my data frame data structure of a pandas class. See, in pandas, just to store data, we have three ways. The very first one is your one-dimensional data structure. That is exactly your series that holds one-dimensional data. The two-dimensional data gets holded by my data frame. That's we often use. Again, if we have a three-dimensional data, in such scenarios we can use or we can think of using this panel data structure. So these all three are the data structures of especially pandas module. So that's all about this session, and I hope you love this session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing. Hey folks, in all our previous session, we have analyzed our data up to a greater extent. So in this session, what we have to do is we have to perform something known as word cloud analysis. That is exactly my text analysis. So the very first problem statement is all about, of course, whether my customer type influence my customer rating or not. So inside this customer type, we have two categories, of course, my member and my normal, which are exactly these one. So anyhow, we have to come up with this conclusion, whether they will influence the customer rating or not. For such use case, for such problem statement, where we have to analyze whether my customer type influence customer rating or not. So we have basically three ways to do this. The very first one is you can think of using our distribution plot. This is the very first way. The second way is you can think of using, of course, my box plot, because box plot is nothing but my extended version or a improved version of this distribution plot that returns my 5-point summary in descriptive statistics. That's what my box plot will do. And our third way is you can also prefer something known as swarm plot. Again, there is just a basic difference between this box plot and this swarm plot. So what this box plot will do, it returns our 5-point summary. That's what my box plot will do. But this swarm plot, what this do is, it will just return a distribution of the data points. There is just a basic difference between this distribution and a distribution of the data points. There is just a basic difference between both them. So let's try to implement all these things, of course, using Python. So I'm going to say sns.swarmplot. We have this swarmplot function available in my Cbound module. And if I will press Shift plus Tab, you can check out all the signature of this function where we have tons of parameters to play with that. Of course, on x-axis, what I really need to mention is, let me show you. This is exactly that feature, which is customer type, that I have to mention on x-axis. Then On y-axis, what we have to mention? We have to mention our rating, because our problem statement is whether my customer type influence rating or not. That is exactly my problem statement. So I will say on y-axis, I will say this is my rating. Then I have to mention what is my data frame. So I'm going to say data is nothing but, of course, my sales. And if, let's say, if I will execute this line of code, now you will see this is exactly distribution of data point in case of member type, and in case of normal category, this is exactly the distribution. So let's try to make it more user friendly. So what I will say is, I will say, let's use this hue parameter, and I will say, let's distribute data points on the basis of my city feature. And if I will again execute this line of code, now you will see these blue data points are with respect to young gun, and these are all the different color data points that are associated with all the different categories of the city. And from the distribution, you can say my customer type will not affect rating, because my upper bar in both the cases is slightly close to 10. That's a basically meaningful insight from this analysis. So our second main problem statement is, what are my most favorite products of the user? Of course, from this analysis, there are two ways to perform this. So the very first one is, you can get some high level overview, that is of course known as my word cloud. This is the very first way to perform this. The second way is, just to come up with this conclusion, the second way is, you can use some plots and chart. Inside this plots and chart, if you have more than, let's say, if you have, let's say, 10 products, so in such case, you can think of using bar chart. Imagine you have, let's say, less product, let's say 3 or 4. In such scenarios, you can think of using this pie chart, because if we have less categories, of course, pie chart plays a very better role. But if we have more number of categories, then you can prefer this pie chart over this pie. So in this session, let's try to get a high level overview, of course, using this word cloud analysis. This is one of the amazing analysis that we perform in the real world. So to perform this word cloud analysis, you just need a single module that is often known as word cloud. So if you haven't installed it earlier, you can simply install using this pip command. So I'm going to say pip install this word cloud. That's it. Just execute it and your word cloud gets installed in your local environment. Now I'm going to say, from this word cloud module, what I have installed over there, I have to import a class, which is exactly my word cloud class. So I'm going to say, let me just import this word cloud class that is responsible for performing my word cloud analysis. So let me just execute this line of code. Now what I'm going to do is, I'm just going to initialize this word cloud, and let me show you one more thing. And if I will press Shift plus tab over there, that's all about the signature of this function. Here you have some width of the word cloud, some height of the word cloud, and you can manipulate it as well. It's all up to you depending upon your needs. And here we have tons of parameters that you can play with that. We have some regular expression, we have tons of things to manipulate your font size of the word cloud. We have font step, and in what mode you have to showcase your word cloud. We have tons of parameters over there, and you can check out all the documentation. It's not a rocket science. Now what you have to do is, once you initialize your word cloud, the second step is, you have to generate your word cloud. This is the second step that you have to do, because anyhow you have to end up having some conclusion. You have to find some meaningful insight. So you have to generate your word cloud, and you need a high level overview of what are the most favorite products of my users. This is the main problem statement that you have to analyze. So very first we will initialize my word cloud, and this is the way how you have initialized. Now you have to generate it. So to generate it, you need some data. Of course, as we are in the world of data, you need some data to come up with some conclusion. So anyhow you need some data. So what we will do is, we will say, hey, we have a feature which is exactly my product line, and in this feature we have all the data that I exactly need to perform this word cloud analysis. So what I will do is, I will say, just collect the entire data of the product line and just pass it to my word cloud, and what this will do is, it will just create a word cloud for us. That's what my word cloud class will do for us. Again, there are two ways to collect this data. The very first one is, you can use some basic loops. You can use just basic loops on top of your product line features, and you will store all the data in some string or whatever data structure you want. It depends upon the use case, and of course it depends upon how efficiently you store your data. The second way is you can use some inbuilt function of Python. You can think of using this join function. So let's try to do it using this join function, and we will prefer it over, of course, using the basic loops. So I will say basically very first we have to access our product line feature. So I'm going to say let me very first access this feature and let me execute. You will see this is the all data that we have to pass, of course, to my word cloud, but in the form of string data structure. So what I will do is I will say just store all the data in the form of a string. So you can use some basic loops or you can use a join function. So over here I will use this join function and I will say just join all the observations having a space separator. And if I will execute this line of code, this is the entire data that you have to pass to your word cloud. Now what I will do is I will say on top of this I'm just going to call an inbuilt function which is a generate function, and I will say hey, just generate a word cloud and my data is this. Again, you can manipulate all the custom parameters that you have. Let's say hey, let's say I want to manipulate my width of the word cloud. So I will say let's say 1920. In a similar way you can manipulate your height. Let's say my height is let's say 1080, whatever you want to mention. Now what I will do is I will say let me just execute this line of code. Now what exactly it means? It means we have a word cloud that is from this word cloud class, and that stores at this particular address. Now what we really need to do is we need to store this word cloud somewhere else. Let's say in word cloud. So once I will store this word cloud in my word cloud object, now what we have to do is we have to showcase this word cloud. For this I'm going to use a function which is the IAmShow function, and what I will do is I will say just showcase this word cloud. That's it. Now let me again execute this line of code, and this is the amazing word cloud for which we all are waiting for. But still there are some manipulations that you need to do. The very first one is you can disable the access, because here access makes no sense. So what I will do is I will say plt.access. I will say just disable it. So I will just pass this off parameter. Now what I will do is I will say let's say just customize the figure size. So I will say plt.figure. Over here we have a very handy parameter which is exactly figure size. Over here I can pass whatever value you want. It's all up to you. Now let me again execute this line of code, and just in a while it will give us some amazing word cloud. Now from this amazing word cloud, now you can see these are some of the products where my users are going to emphasize more. Again, these products are primarily related to my fashion products, lifestyle products, and of course health accessories and lifestyle, some of the beverages, and of course some of the traveling things like that. So these are some of the products where users are going to focus more. So this is the key insight that I can showcase to my stakeholder, and I can say hey, these are the key insights where you can focus more and you can increase your revenue. So that's how actually you have to overcome with the problems in the real world. So that's all about this session and this project as well. I hope you love the session very much. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.